This is the last of the lectures about the basics of probability, and in this one we're going to talk specifically about how we calculate the probability of an event. So when we're talking about probabilities of events, we're talking about numbers that, like proportions, range from 0 to 1. And like the proportions of all the different components of a mixture, the individual probabilities of every possible outcome of a random process must sum to 1. So, classic example of flipping a fair coin, there are only 2 possible outcomes, and each one is equally likely, so they both have the same probability of occurring, which is 1/2, or 0.5. And if we have a fair die, which has 6 different options, and each is equally likely, then each face of the die has a chance of occurring of 1 in 6, or a probability of about 0.17. Now, every outcome doesn't have to have the same probability. They're not necessarily all equal, but it is easy to explain things with fair dice and fair coins. So, just to emphasize that there are some pretty specific rules about how probability works, the first thing is that 0 is the lowest possible probability. So if something can never happen, then its probability is 0. So if we had a writing competition where it was only for sophomores, then the probability that a senior would win that writing competition would be 0. The probability that the valedictorian of this college will be a Carthage student is 1 because it's guaranteed. Only Carthage students can be Carthage valedictorians. The larger the probability is, the more often we expect it to occur. That goes back to the definitions of probability. That was the previous video. Or 2 videos ago, right? So that someone finishing their 4th year will graduate is an event that we think will be more probable than someone finishing their 1st year. So the probability is higher. And the final thing is that there's a complement to the probability of something, is the probability that it won't happen. That's complement with an E, not with an I. And to find out the probability that something won't happen, you take the probability that it will happen and subtract it from 1. So 1 minus the probability that it will happen is the probability that it won't. Finally, there's some notation, because mathematicians like me are lazy and they like to write as little as possible. So if we have a sentence that says the probability of X occurring is 0.25, then we write it like it's written here. You have a capital P, X in parentheses, equals 0.25. And then you can oftentimes, when we're calculating things, we don't know beforehand what the probability is, so we're doing some algebra, so we represent that value by a variable. Oftentimes it's lowercase p, because not only are mathematicians lazy, they are also not creative. And so then the probability of something not happening, px doesn't happen, is 1 minus p of x. So sometimes we say p of x also. So those are some notation terms that you're going to encounter. Now, the next thing that's important to understand about probability is that there are 2 kinds of probabilities. There's discrete probabilities and continuous probabilities. Notice the way this is spelled. If it was discrete, that would be discrete, like what happens in Vegas stays in Vegas. This is discrete, which means that you have isolated outcomes with no intermediate. You can have a lot of different outcomes. So I've got this picture of a chain, because you're either in a link or you're not in a link. These links are connecting a chain, but they are not continuous. You can see where one link ends another. Likewise, when you're rolling dice, if you roll 2 dice, there are 11 possible outcomes. You can't get a 2.5 when you roll a pair of dice. So when we show these with things like bar plots. So here's the actual proportion of times that we rolled the different outcomes when I rolled a bunch of dice. In contrast to discrete variables, we have continuous probabilities, and those are like a river, where there are little droplets in the river, but you can there's no specific point. And we often measure them with things like calipers, where you can get as exact as you want. You can measure out to as many decimal places as you want. And there are an infinite number of in-between values. And we draw these as curves with shaded parts below them. And so the probability is equal to the area here. So I probably should have not gone into detail in the last slide, because I just repeated myself here. But so we have situations where we can label, name, identify, specify, point out, and or isolate each outcome, that is a discrete outcome. And so when we say the probability of X is a discrete thing. So the probability of rolling a 5 is exactly one thing. And we plot them as bars, like I just said before. So here's an example problem. You'll have something like this in the problem set. Let's say a vending machine contains 20 gumballs. 8 of them are pink, 7 are blue, and the rest are white. What is the probability of getting a white gumball? Well, I didn't tell you exactly how many white gumballs there are explicitly, but I gave you enough information to figure it out. So to solve this, you have to figure out how many white gumballs there are, and then figure out the proportion out of 20. So first, we take the 20 total, we subtract the 8 pink and the 7 blue. That gives us 5 white gumballs remaining. So then the proportion is 5 out of 20, or 25%, or 1/4. So probability of getting a white gumball is 0.25. If I was doing this as an example problem, I might have like 8 out of 20, 7 out of 20, 5 out of 20, and 15 out of 20 as the different options in the multiple choice, and attempt to try and trick you with intermediate values. Now, the probability of continuous outcomes, we can't talk about specific outcomes. You never have the probability of something is 0. You always have a range, because with continuous numbers, you can always look at more decimal places and say, okay, well, you wrote 0. So like here, when we're saying 2, it actually could be 2.00001, or more zeros to 1, and more zeros to 1. They're all close to 2, but they're not exactly the same. So we can't say the probability of 2. We'd say the probability of getting between 1.9 and 2.1. So you can, inside the parentheses, you can have like this range notation. And then another way of saying that would be the probability that X is within 1/10 of 2. So that would be like in this region here. So we would find the height, we look at this little region here within 0.1 on either side of 2 and find the area of that, and that would be the probability of the continuous outcome. So here's an example problem. So if I tell you that a cider maker measures the sugar content of her apples and finds that 2/3 of them have less than 18 grams of sugar per apple, and 4/5 of them have more than 14 grams of sugar per apple, what is the probability that an apple has a sugar content in that range between 14 and 18 grams? So this is a little bit trickier again, but just like the white gumball problem, the trick here is to figure out some opposites. So if 2/3 of them have less than 18 grams of sugar, then 1/3 of them have more than 18, so they're outside the range we're interested in. Likewise, if 4/5 of them have more than 14 grams of sugar, then 1/5 have less than 14, so they're outside the range. So we've got 1/3 up here and 1/5 down here, outside the range. So that means that, so 15/15, 1/3 is 5/15, 1/5 is 3/15, so we have 7/15 of the apples are in the middle range. So that's about 0.47. So that's how we would calculate this. So we don't actually need the picture in this if you have a carefully worded problem, which you will get. That's it. Here's a review of all the different basics of probability that I talked about, and you better believe that the problem set will have questions about each of these things. So thank you for listening, and hopefully you are feeling like you know a bit about the basics of probability.